Hi and welcome everyone. So in this video, I want to look at why I think Blazor is way better on .NET 10. I hate to make React the villain in this because I love React, but I do prefer to work with Blazor where possible, and after the release of .NET 10, my preference for Blazor has even strengthened. So in this video, we'll look at some of the improvements and enhancements that have been shipped with .NET 10 for Blazor. And in this context, I'll discuss why I prefer to work with Blazor rather than React for creating apps that require high-performing interactive front ends. So, stick around to the end where I demonstrate the new Blazor features that have been shipped with .NET 10. I was checking out some of the videos from .NET Conf 2025, notably from Daniel Roth, who is the principal product manager for .NET Core and Blazor on the .NET team. And one of the core reasons why I'm bullish on Blazor is because of how Blazor is consistently improving with each release of .NET. As you probably know, a version of .NET is now released every year in November. Yes, React is more mature than Blazor and has a much larger ecosystem, a lot more third-party components to choose from. And this can be a blessing, but it can also be a curse. Wait, hear me out. Blazor may have a smaller ecosystem, but it seamlessly integrates with the huge, mature, and extremely powerful .NET ecosystem. This makes it easy and seamless to integrate, for example, the latest AI.NET features into your Blazor apps. This year's .NET Conf 2025 showed me how the right aspects of Blazor are getting attention. For example, delighting developers by addressing pain points that have been frequently highlighted by .NET developers. So developers are being heard and their concerns are being addressed, which is excellent. For example, validation is now automatically done for nested models. I'll show you the details of this later on in this video. New security features have been added, like for example, making it easy for developers to integrate the use of passkeys into their applications so that passwords are no longer needed to authenticate with Blazor applications. Users can now easily authenticate using, for example, their biometrics scanned from their phones or on Windows devices using Windows Hello or their Windows PIN. With passkeys, a private key saved on an authenticator application and a public key saved to the server are used for authentication. This means a password is no longer needed to be sent from client to server in order for authentication to take place, which mitigates certain security risks. Passkeys are, for example, great for phishing prevention. So passkeys make authenticating with Blazor apps a lot more convenient for users, as well as provide extra security benefits. Observability and diagnostics have been improved with the release of .NET 10. A lot of new Blazor-specific metrics are now available. For example, metrics pertaining to page navigations, UI events, how many active circuits you are running. Improved tracing for Blazor Server has also been included with .NET 10. For example, you can see the activities associated with specific page loads and events. Diagnostic tools have been added for Blazor WebAssembly so you can collect performance profiles, memory dumps, and runtime metrics. The easiest way to see new metrics and tracing is through Aspire. It was formerly called .NET Aspire and now should be referred to as just Aspire. You can include Aspire within your projects either at the point of creating a new project in Visual Studio. I'll show you how you can do this a little bit later. Or you can add Aspire to existing projects. Aspire is a cloud-ready application stack introduced by Microsoft to simplify building distributed, observable, and production-ready .NET applications. Its benefits mainly revolve around productivity, reliability, and easier cloud operations. So during the development phase, you are able to use Aspire to diagnose issues and evaluate performance metrics, which can help you to potentially make your Blazor applications more efficient and robust. Aspire has been improved for displaying telemetry and diagnostic information. While I was looking at some of the .NET Conf 2025 videos, particularly with regards to some of the enhancements and improvements shipped with .NET 10 for ASP.NET Core and Blazor, I was reminded why I prefer to use Blazor over React where possible. This reason is largely to do with maintaining the application once you've created it. One of the advantages of using React is its huge ecosystem, loads of third-party components to choose from. This, in one sense, is a huge advantage. However, it can also result in a huge maintenance nightmare if you are integrating large amounts of third-party components into your applications. I would rather use less dependencies in my apps from third-party providers that are proven to be reliable, so when subsequent versions of the relevant dependencies are created, they are reliably created with backward compatibility in mind. So loads of third-party components integrated into your apps can provide you with rich functionality, but also a lot of headaches as new versions of those third-party components are shipped. There's always this sense among software developers that an application is never really finished. So with software, there's generally an endless amount of maintenance and customizations keeping software developers busy. This type of work is arguably much easier when you limit the amount of third-party created dependencies in your applications, and it is important that those third-party dependencies that you include within your applications are created and maintained by teams that you trust. For example, I recently created this Golang React movie streaming full stack web application course. You can see this course on the Free Code Camp English YouTube channel if you're interested. I had already created the React front-end movie streaming display functionality using a third-party React component for a previous project and wished to use this functionality in the Golang React full stack web application project. So I thought it would be really simple to just copy that code from the earlier created project into the new project. So I did just that, assuming that the latest version of the React movie streaming display component functionality would be backward compatible. But when I ran the code, of course, nothing worked. So firstly, I tried to fix the code so that it would work with the latest version of the component. So I spent a lot of time sifting through documentation to find the correct code, but I couldn't find anything that helped. I'm sure if I had persisted, I would have eventually found the code fix, but I decided the process was taking way too long for what it was worth. So to fix the issue, I uninstalled the latest version of the component and installed the version that I had used in the previous project from where I copied the code that leverages the relevant component. And of course, that worked, but it was not ideal. Presumably, the latest version had been enhanced and improved, but it also had a lot of breaking changes, so of course, it was not backward compatible. The point is, the maintainers of the code had introduced breaking changes in subsequent versions, and this had created a time cost for me, attempting to upgrade my code so that it worked with the latest version of the relevant component. So maintenance of backward compatibility is so important in my opinion. When this process is managed by a reliable source, this pays dividends later on when the developer upgrades the dependencies to the latest version. Upgrades to those dependencies are made hopefully with backward compatibility in mind. Please share with me in the comments your tales of woe when it comes to maintaining software. Let's commiserate together. Let's have ourselves a pity party. We've earned our pity party after years working in the trenches in third-party integration hell. Of course, all comments are welcome. I love reading your insights. If you are liking this video so far, please hit that like button and please consider subscribing if you haven't yet subscribed to the channel. Please also ring the bell so that you'll be notified of newly released content. Please share this video with anyone you feel may benefit from its content. If you'd like to thank me by buying me a coffee, you can do that at my Buy Me a Coffee webpage at this URL. It would of course be greatly appreciated. So going back to React versus Blazor, another simple example to illustrate my point would be form validation. With Blazor, the validation mechanisms are reliably integrated into .NET, and upgrades to the validation functionality are managed centrally. So the management of the .NET components feels more centralized, unified, and more reliable. With React, you have several third-party options to choose from. I'm not saying they are all terrible, but to be honest, I have more faith in such foundational functionality being managed more centrally, like is the case with .NET components. There's a sense that React apps are potentially more messy in terms of maintenance. The more third-party dependencies you have, potentially the more headaches you're also going to have. Please push back in the comments section if you disagree. This is just my personal opinion. Before I demonstrate some of the newly enhanced and improved Blazor features that have been shipped with .NET 10, I want to highlight that I was delighted to see that Blazor is being successfully used by many reputable companies to develop their software. The MyRide K-12 app provided by Tyler Technologies has been created for the web as well as native devices using .NET MAUI Blazor Hybrid. This app helps parents track student bus routes and transportation schedules, and is used by over 2,500 K-12 schools across Canada and the United States. And it has over 750,000 downloads from the Google and Apple app stores. This is just one example, and I'm sure Blazor is going to become a popular choice for native and web apps moving forward. With hybrid apps, you can reuse your Razor components across both web and native platforms, allowing developers to be maximally productive. The MyRide app is built by a small, agile team with incredible results. When the team updates one component, it can be propagated across both web and native platforms automatically. This increases agility and reduces costs. In Daniel's demonstration, he also mentions another company, LKAB, Europe's largest iron ore producer, that has transformed its mobile strategy by using .NET MAUI and Blazor. So many companies in the future will be adopting .NET MAUI and Blazor for their native and web apps. So it is a very exciting time for Blazor developers. Right, let's look at some of the new features shipped with .NET 10 for Blazor. Let's start with simplified security, Passkeys. Right, so we're going to be looking at how in the new version of Blazor on .NET 10, how simplified security has been implemented. So we're going to look at a quick demonstration of the effects of that, and it involves creating a passkey for your application. So you must understand the passkey. Each passkey is scoped to a particular application. So I've actually downloaded and installed Visual Studio 2026, which automatically installed .NET 10. So if you want to follow along, I recommend that you do that. And you can see here we've got the passkey files included within our project here. And I'll just take you through how I created this project, this Blazor project. So let's go to File, New, Project Solution, and then you select Blazor Web App. That's the project template we're going to use to create this project. And then click the Next button. And then you want to give your project a name and obviously find a folder locally that you want to store your project in. So we're creating a new solution here. That's all looks good. And then press the Next button here. And you can see here I've got .NET 10 long-term support. As I said earlier, when I installed Visual Studio 2026, it automatically installed the latest version of .NET, which is .NET 10, which has recently been released in November of this year, 2025. And the next thing I did was I selected individual accounts for this authentication type field. So it's going to set up all the relevant tables in your database for authentication when you create your project and run the migration. The migrations will be included in that project, and then you must run the migrations against a designated database. So we're going to choose server mode for interactive render mode. And then what I did is I enlisted .NET Aspire orchestration, and incidentally, .NET Aspire is now just called Aspire. Enlist in .NET Aspire orchestration, and then you create your project. I'm not going to create a project, but this is how I created the project that I'm using here for demonstration purposes. So I'm going to run this project now. So you can see here, this is the .NET Aspire, the Aspire UI here, and with this interface you can check various metrics, and we'll touch on that a little bit later. For now, what we want to do is just look at the project that we've created. So the first thing we want to do to create a passkey is we want to create a user. So I'm just going to call this guy Dan Jones. I've already created Bob Jones. So Dan Jones at hotmail.com. Okay, and then let's register Dan Jones. Great, registration was completed successfully. I'll just save that locally. And then you click here to confirm your account. So ordinarily in production, when a user registers, an email will be sent to that user's registered email address. And then the user will click a link within that email address to confirm that that is indeed that user's email address. But just to make things easier during the development phase, we've got this link made available to us, so we can just click that to cover that part of the authentication process. So click here to confirm your account. Let's do that. Great. Thank you for confirming your email. So we've confirmed that. Dan Jones, let's log in. Hello world. And you can see now this auth required web page should be available to us, whereas when we're logged out, I'll show you that in a bit, we won't be able to see this content because we are not authorized. We're not authenticated. Then to create our passkey, we select this link here that has now appeared to us since we've logged in. And then to create a passkey, you just click this Passkeys link here, and you can go add new passkey. And now we're being prompted to authenticate. So you could use Windows Hello or external authentication key. So I'm going to click that there. So if we continue with this will be saved to your Windows device. So let's press continue. And I'm going to just authenticate using my Windows PIN. You could have used Windows Hello also. So I've now authenticated there, and then you want to give your passkey a sensible name. So I'm just going to call this Dan's passkey to keep things simple, and then press continue. And now we've created a passkey, so we don't have to authenticate in future by logging on with a password because we've created a valid passkey. So when a passkey is created, a private key is created within your authenticator, and a public key is created on the server. So the public key, as alluded to by its name, is public, and the private key is private. The private key is saved to an authenticator application, whether it's on your mobile phone or on your Windows device. And we've actually saved our private key on the Windows device, and we are authenticating now with our Windows PIN. So we'll see that now, how that works. So let's log out. And you can see now, if I go to auth required, we are presented with the login page. So you can see here, if I'm at home page and I go to auth required, it takes me to the login screen because we need to authenticate. But now we can log in rather than with our email address and password, we can actually log in with our passkey. So let's do that. Let's go log in with a passkey, and let's choose Dan Jones. Let's insert our PIN here. And we've been logged in using our passkey. Excellent. You can see we're now logged in. We can see you are authenticated here. Homepage, you are authenticated. And when we log out, of course, we cannot see the auth required web page because we're logged out, but we can always log in again using our passkey. Okay, so now we're going to look at form validation and how it automatically enables the validation of nested objects. So .NET 10 now ships with functionality that will automatically enable your forms to include nested objects, and it will automatically validate the fields for those nested objects. So I'm just going to demonstrate what I've done here. I've created possibly the ugliest registration form in history here, but it'll do for our example. So it's just typically how you would create your form. You've got your data annotations validator element here within your edit form element here. So this is just a basic form. We've got our registration form fields, first name, last name, email, URL, password, confirm password. But then we've got these address fields, and these come from a separate object to these fields here, the first name, last name, email. These are part of the parent object, which is the register model. Register model here, you can see register model. We've got a type here, and the address fields, the address properties are part of a separate address object that is instantiated from an address model, which actually resides as a child object within the parent object, which is the register model. So let's look at that. So if we go to this models folder here, you can see I've got address model here, and you can see here that we've got the address fields here. And then this address model is also part of the parent model, which is the register model. And you can see here we've included various validation attributes so that the first name, last name is required, email address is required, but we're also validating the format of that email address as well as the URL format here with these attributes. And then we've got these required attributes here for all of the fields actually. But then notably, we've got this address model type here, property. We've got this address property, which is of type address model here. And this is our nested child object. And you can see here, it's very important that you instantiate this model within the parent model, or else it won't work. So we've got this validatable type attribute here. So what we're accomplishing here is that it will automatically dive into these fields, the fields that are contained within this address model type, and those address model fields will be validated according to whichever attributes have been applied to the address model fields here, these properties here. So address 1, address 2, these are required fields. And then you've got this one, which is a property that contains the most complex validation criteria, and we're using a regular expression to validate that this postcode is a valid UK postcode. And this is what this regular expression data is all about. Postcode is not valid. Postcode is not a valid UK postcode if it doesn't match. If what is entered for the postcode field does not match this regular expression here. So let's see that in action. Oh, wait, just before we run the code, one thing you will have to add is you'll have to go into program.cs and add this line of code here, builder.services.add_validation. So it adds the relevant validation, the new relevant validation services that are needed for this nested validation functionality that ships with .NET 10 for Blazor, and also for ASP.NET Core in general. So let's run this, and let's look at this rather ugly registration form that I've created. But functionally, it's pretty sound, and you'll see the nested functionality in action. So we've got the .NET Aspire UI first displayed to us because we included Aspire orchestration when we created the project. But let's click the relevant link here and run our code. And let's go to register here. Now, the first thing I'm going to do is I'm going to hit the register submit button here. And of course, our validation criteria kicks in, and we've got some red messages displayed to us stating that first name is required, last name is required, etc., etc. We need a valid URL here. So then, of course, when we enter the relevant fields and tab to the next field, it validates accurately. Excellent. Okay, so Dan's, let's go HTTP. dansworld.com. Okay, let's go there. Do some basic validation. 12, right? So for the address, just insert block D just for the sake of this example. Postcode. So let's firstly enter an incorrect postcode. So 6A, and let's tab. Okay, postcode is not a valid UK postcode. If we add Y, for example, it is now valid, and we're ready to submit the form. So what it's done there is it's automatically validated the nested child fields here. And this is a new feature that's been included with .NET 10 for Blazor. So it will just automatically, out of the box, validate those fields. With a few minor tweaks, it will include validation for nested objects like it has done here. And let's hit the registration button, and there you go, registration submitted successfully. So that is validation with .NET 10. So you can declaratively ensure that the state for your Blazor server components are preserved, even if, for example, the circuit is dropped. For example, if the user decides to open a new tab and explore another web page, then moments later decides to come back to your page. So I've included this JavaScript code that I actually copied from Daniel Roth's demonstration at .NET Conf 2025. So this has been included within the app.razor file. And what it does is if the visibility change event is fired, it checks if the document is hidden. And if so, it pauses the circuit responsible for communicating from client to server for user interactivity functionality, for when user interactivity functionality is performed against the web page. So it will actually pause the circuit, and when you go back to the page, it will resume that circuit running. So it will bring up that circuit again. So the circuit will resume when the visibility change event is fired again, but the document this time is not hidden. So the circuit will resume there. And what we want is when this visibility change function first fires, so for example, when the user opens a new tab from the web page, goes to surf the internet or watch a YouTube video or whatever, and then decides to go back to your web page, your application's web page, and the circuit is resumed, that the state for that page is still there. So when it actually pauses the circuit, it saves your state. The state of your web page is also saved. So when that circuit is resumed, it remembers the state of that web page for when the user goes back to your web page after watching a YouTube video or surfing the net or doing whatever. So firstly, I just want to show you the counter page. You can see here I've actually included the new code here, but it's commented out. I just want to show you what would ordinarily happen with your counter state when a user clicks off your web page and goes to another web page. Let's just see what happens to the state of that counter variable called current count. Okay. Great, so we see the Aspire UI first shown to us. Let's go to our application by clicking the appropriate link. Hello world, let's go to the counter component here and let's click this button a few times to increment the current count variable, which is displayed to us automatically. So we've got great user interactivity functionality here. It responds to us almost immediately when the click me button is clicked. But now if we open a new tab and we go back to that, you can see the state for that current count variable is lost. So the state for that particular field is lost and we want that preserved. Okay, so let's try that again. Let's alter our code just a little bit and then we'll try it again. So you can see here I've already written the code there. I'm going to comment that back in there. And we're going to comment this out. That's the old code, keeping the current state for the current, keeping the state for the current count variable. So the crux of this is this must be a property. So we've changed current count to a property here. And then we've added this persistent state attribute. So we're telling Blazor we want the state preserved. So that means when the user now clicks off our web page or opens a new tab and goes surfing, so the focus is no longer on our counter page, it will preserve that state. It'll save that state to the server before that circuit is then paused. So that circuit is dropped. So before that circuit is dropped, the state of this current count property is saved. And let's see that in action. So let's press the play button, run our code. And let's go to navigate to our application from Aspire. And let's go to the counter page here. Let's click this a few times. So you can see current count is 5. And we don't want that to go back to 0 after we've surfed the internet, for example. So we do whatever here and let's go back. And look, it's still 5. That's what we want to see. So it's preserved the state for our web page. So even though when the counter page loses the focus and the circuit is dropped, its state is still saved. So that when the page gets the focus back and the circuit resumes, the saved state is preserved and the user can continue to increment the count from the counter value that was saved at the point where the circuit was dropped. And if we show the metrics here, we can actually see the circuits being dropped and then resumed. So circuits active. You can see here we've got a graph showing the circuits active, and let's see what happens when we click off this here and how it affects that. It's dropped. You can see that there, the circuit is dropped. And then if we go back, it should resume, and it does, it resumes. So you can see that in real time using Aspire metrics. It's actually a very cool piece of functionality, this Aspire. So let's go there, click it. Current count is 8, and let's go to a new tab. So it loses the focus, and you can see now in real time that that circuit is being dropped. Brilliant. And then when we go back, our state is preserved at 8, and the circuit is now resuming, and you can see that in real time through Aspire, which is awesome. and continue from 8. Excellent. If you want more detailed demonstrations, please check out some of the videos created for .NET Conf 2025. It is very encouraging to see that Blazor and ASP.NET Core are being well supported by Microsoft. The future for Blazor looks bright to me. I've included a link to Daniel Roth's .NET Conf 2025 video demonstration below in the description of this video. I hope you have enjoyed this video. If you've liked this video, please hit that like button and please consider subscribing to the channel if you haven't yet subscribed. Please also ring the bell so that you'll be notified of newly released content. Please share this video with anyone you feel may benefit from its content. If you'd like to thank me by buying me a coffee, you can do that at my Buy Me a Coffee webpage at this URL. It will of course be greatly appreciated. Please let me know in the comments your thoughts on Blazor's future and if you prefer working with Blazor or React. And please let me know your reasons for your choice. All comments are of course welcome. I love reading your insights. It would be great if you would follow me on X. My username is @GavinLonDigital. I hope to see you soon. Thank you and take care.